Hello there, 8th graders, and welcome to our science class for week number 19. Just like every week, thank you a lot for coming, completing all of the online assignments that you have, and of course for attending the online class. So be welcome for today's lesson. Before we start, just like every week, log into Agilix, enter to the Google Classroom, download your Word document, save it inside your science folder, and of course, name your file as it is specified right below. It is always very important to start with our end in mind, and today we're going to study topic 3.02, and the end in mind is the following. Students will be able to determine sources that connect to groundwater in order to successfully complete the lab report of topic 3.02. Make sure to keep track of it in your Word document. Alright, so now we have a very disgusting picture as a background, but unfortunately it's a reality in several places around the world. So that is going to help us out to have a small introduction. So for this introduction, please watch the video on page number 1 of topic 3.02 and read the introduction for the topic. So there you are going to find some more information about how we are going to relate today's topic to the image that we have right here. Once you are done with that, you can come back to the video and we can continue with our lesson today. Alright, so welcome back. Today's topic is groundwater. And we're going to analyze some very important concepts from groundwater. So water exists above the ground as well as under the ground. What happens is that in the previous topic we studied surface water such as rivers, tributaries, lakes, seas, so on and so forth, many other water resources. But what happens is that we also have some water resources under the ground. So let's imagine that there are some sort of rivers or some sort of lakes that are underground as well, which are generated by some chemical reactions that we will see later on. Some water is recycled during the water cycle. Of course, we already studied the water cycle in which water evaporates and it condenses, it becomes rain, and then it comes back to the ground. But what happens is that while some of that water stays in the rivers, lakes, or at the top of the surface, there is some other water that actually goes under the ground. Some other water penetrates inside the ground, and that is what we call infiltration. So infiltration basically means that water is going to go right below the ground. We also have another important term, which are aquifers. And they are places underground that storage water. And permeable rocks allow water to flow through them. So what happens is that these aquifers are very similar to, let's say, a lake, for example. The difference is that usually aquifers are going to be full of rocks, but those rocks have certain properties that allow water to flow through them. So there is like water inside those rocks, but when a lot of water is stored inside those rocks, we find what we know as aquifers. We also have a water table, which is the top of an aquifer. I'm going to show you a little bit later what it looks like. And all of this can be affected by human activity. So let's suppose that humans start using these sources of groundwater that they have right next to their town. So what happens is that if they overuse it, and they use more water than the one that the aquifers get from a rain and from the infiltration of water, what is going to happen is that this source of water is basically going to dry out because they are not like unlimited resources. Alright, so here we have an example of what an aquifer looks like and all of the things we were learning before, okay? So right here we have the aquifer. It is what I was telling you about. Even though it's a portion of rocks, they contain a lot of water inside of them. And also we have something called the saturated zone, which is like the bottom part of the aquifer. We also have the water table, which is what we find right at the top of the aquifer. We also have a well where people put a bucket inside and where they take water from. Also a spring, which is like a break on earth crust that is going to allow the water from the aquifer to flow out. Irrigation, which is basically the use of humans in order to water their plants. And lastly, we have the recharge, which basically means that the aquifer is going to get more water from the rain and of course from the infiltration that it will have when it goes back to the ground. Let's continue. So now, I would like you to complete this specific activity that you have on page number 2. And it's something very interesting because they are going to give you some very important vocabulary right over here. They are going to give you a definition and they are going to help you out to check your understanding from these words right here. So please go to page number 2 and complete the exercise that you have right here. Only read the definition, type down the word that you consider is correct, and then click on check your answer to see if you got a correct answer. You need to continue until you have completed all of the words from this table. So go ahead, I will be waiting for you. And once you are done, please come back. Alright, so now, extra point alert. If you would like to have an extra point today, go to page 2 of W3.02 and complete the Try This at Home section. So this is something very interesting. They are going to ask you to create something similar to what you can see right here in the picture. And it's some sort of a smoothie which includes soda, ice cream, and many different things. So I would like you to complete this activity because it will give you a better perspective on what aquifers and all of the parts that it contains have. So I just encourage you to use all of the materials that you have at home. You don't have to use necessarily ice cream and soda because right now you really don't have to go out, okay? So please stay at home. Be creative, use the materials that you have right there, complete the lab that you have right here, and if you would like to have an extra point, make sure to submit it. Remember, this is just an optional activity. It's for an extra point, but if you would like to have it, you can go ahead and do it. Alright, so what are the effects of groundwater? So when water infiltrates, it starts to dissolve sand. Therefore, it generates the creation of underground caves, lakes, and rivers. You may remember the picture that I showed you before, and just that you could see the sand, what's starting to be affected in there. So there are some parts in which we will not find any more sand, but it will be merely just water. We also have something that are called stalactites, which are formations of sand that come from the ceiling to the ground. And this is very interesting because when the groundwater starts flowing underground, of course, it starts changing the composition of sand, of milestone. And thanks to that chemical changes that it presents in those materials, stalactites are created, as well as stalagmites. And they are the formations of sand that come from the ground to the ceiling. We also have another important principle, which is the karst topography. So, which is basically the changes of the land caused by groundwater. Alright, so here we have a little example of how humans use groundwater. As you can see, they have to penetrate through soil, through sandstone, and at the end they are going to find an artesian aquifer, okay? And right at the bottom we are going to find rock that is a little bit harder, but remember that the water cannot flow through these rocks that we have right here. It will only flow through the materials that we have right above. Alright, now we have some examples. The lakes in Florida were caused by a karst topography. This refers to chemical reactions between acid and limestone. We also have something called hot springs that are created when groundwater is heated up by volcanic activity. You can find them in Yellowstone Park. And this is one of my favorites, the geysers, formed when water heated up by geothermal energy is forced to go out of cracks of Earth's crust. So here you have an example of a geyser. So basically what you can see right over here is that water is being pushed so hard to above the ground, and of course through one of the cracks on Earth's crust, that we get this effect from there. All right, and we have a very important table to analyze right here. So first of all, we have Earth's water that is right over here. So in Earth's water, we have to notice that we are going to find mostly saline water, which is usually found in the oceans. And we have a very little percent of fresh water. So what is the difference? The difference is the salinity that we are going to get in each one of them. But the one that is ideal for human use is fresh water. Okay, so now let's analyze how we are going to divide this 3% of the total water that we find in the planet. So as you can see right here, we have others that will be 0.9%. Surface water is only 0.3%. So when we talk about surface water, remember that we have rivers, lakes, tributaries, and so on and so forth. But we have a very huge amount of groundwater, which will be the 30.1%. And lastly, we have ice caps and glaciers, which will be a 68.7%. Notice that this water is frozen in the North and the South Pole, so it is not available for human usage. Alright, and lastly, let's see how we divide the surface water. We are going to divide this 0.3% in rivers, 2%, swamps, 11%, and lastly, lakes in 87%. So as you can see, we have a very little portion of fresh water. So it's extremely important that we take care of it. Alright, now we have some key concepts. We have hydrogen bonds. So attracting of hydrogen particles in water molecules. So remember that the chemical composition of water is H2O. So H stands for hydrogen and O stands for oxygen. What happens is that hydrogen is going to attract other particles of water. That is why we have hydrogen bonds in there. We have cohesion, which is the principle that explains that water attracts itself. So if you put some water on your table, you will notice that somehow the water particles are going to attract other water particles. That is what we know as cohesion. We also have addition. It explains the way water is attracted to other materials or substances. Let's suppose that you put some water in a sponge, for example. Then you will notice that the sponge will totally absorb water. So that is the analysis that we're getting. How much water is going to be attracted to other materials? We also have capillary action, which is the capacity that water has to flow through a tube. So let's imagine that you are drinking some water from a straw. Water is going to be able to flow through that tube or through that straw. We also have a very specific heat, and scientists have usually used water as a reference to measure the temperature of other materials, because they already standardized that when water freezes, it has reached a temperature of 0 degrees Celsius, and when it evaporates, it has reached a temperature of 100 degrees Celsius. Alright, so now let's jump to your evaluation. Let's see what you have to do today. Students have to read topic 3.02. Remember that you also need to create a summary just like every single week. Complete and submit the worksheet for topic 3.02. You will find it in page number 5 of this topic. Groundwater Lab Report is the name of the lab report that you need to complete today. Remember, the summary is not the evaluation today. The evaluation today is the worksheet that you will find in page number 5 that has the name Groundwater Lab Report. Okay, and for the rubric, you can check the rubric on page number 5 of the topic we studied today. And that was basically it for today's session, guys. Thank you for coming, and I will be meeting you in a couple of minutes during the Zoom session. You can always let me know if you have any questions in Google Classroom or directly in WhatsApp. Goodbye, guys, and take care.